All compressor manufacturers publish compressor capacity tables for their products. We will be using a Copeland scroll capacity table for our example today. Quick search on the internet and we can access the data that we need to perform advanced troubleshooting. For many manufacturers, there are apps designed for technicians that give them access to the data instantly while in the field. Copeland has the Copeland mobile app, and that is where I found all of the data for our examples today. I'm a huge fan of this app, but I would like to make it clear that other manufacturers have similar applications for technicians that are great to use while troubleshooting systems. For our example today, I am using a scroll compressor that is rated for 24,000 BTUs per hour. What I want to point out is that this is at AHRI testing standards, not conditions in the real-world application. So this compressor is capable of 24,000 BTUs per hour when the evaporator temperatures are exactly 45 degrees and the condenser temperatures are exactly 130 degrees. In a real-world application, we know that this equipment will be subjected to many different conditions throughout the day, the week, and the year. And we also know that airflow can affect the coil performance, whether it is a filter issue, ductwork leakage, humidity levels in the space, or even ambient conditions outdoors. When we look at this performance chart, you will notice that the top horizontal set of numbers refers to the evaporator temperatures and pressures. The vertical set of numbers refers to the condenser pressures and temperatures. When we can use our gauges or temperature probes to come up with the same results. If there are numbers within a block on this table, then the compressor is running within its operating envelope. If the block is empty, the compressor is running outside of its operating envelope and will most likely fail. This is related to the oil return and compression ratios, which we will talk about in other videos later in this series. Capacity is how many BTUs per hour the system can process. Power is how many watts are consumed by the compressor to perform the process. Current is a measurement of the flow of electricity through the system. Mass flow is a measurement of refrigeration effect through the compressor or heat transfer capabilities. EAR is the number of watts to BTUs, and isentropic efficiency is a measurement of actual work performed to work performed under ideal conditions. Another way to look at that would be losses. As technicians, we can use capacity, amperage, and sometimes power and mass flow from these tables to troubleshoot issues within a system. AHRI rating for this compressor is at 45 degrees or 130 psig suction and 130 degrees or 477 psig discharge pressures. I have shown this in green, and you can see that under these conditions, the compressor will be able to produce 24,000 BTUs per hour at approximately 10.6 amps and a mass flow of 353 pounds per BTU. Let's look at what would happen if our suction pressure drops slightly, possibly from a dirty filter or a low load condition in the space. If the temperatures and pressure drop to 35 degrees and 107 psig on the suction side, the capacity drops to 19,200 BTUs per hour at 10.8 amps, and the mass flow drops to 286 pounds per BTU. So we lost 4,800 BTUs per hour by losing 10 degrees of temperature on the evaporator coil. That is a 20% capacity loss, and the compressor still is within its operating envelope. I have highlighted in yellow an example of discharge pressure temperature increase. The example shows 140 degrees at 541 psig in a 45 degree evaporator coil. You will notice that the capacity drops to 21,600 BTUs per hour, so that is a lot less capacity loss. However, look closely at the wattage used at 2,750 compared to 2,400, and the amperage jumped up from 10 amps to 12 amps. So the customer is paying more, the equipment is experiencing an increase in heat from the higher current, and we have a 10% decrease in capacity. Now let's look at a more extreme example. The highlighted box in orange shows that our evaporator pressures and temperatures have dropped to 25 degrees and 87 psig. This may be because of a small refrigerant leak, dirty filters, dirty coils, or even possibly blower speeds. We can see that our capacity has dropped to 15,000 BTUs per hour. That is a 40% capacity loss, and our mass flow has dropped to 226 pounds per BTU. However, our amperage and wattage have not changed significantly, and the compressor is still operating within its envelope. Whether using our gauges or performing non-invasive testing, we can track the performance of a system through the use of data provided from the OEM. Thank you for watching, and I sincerely hope that this video was helpful to some of you out there. Please stay tuned for more tips and tricks for technicians. Follow me on LinkedIn or Facebook. For dates on in-person training, feel free to reach out to me via social media or through my email, dustin.blackstone@emerson.com.